Okay, for homework I had asked you to do on this horizontal projectile sheet numbers 2 to 4 and 8. I only picked those ones because I wanted you to have a bit more practice. You can actually do all of them on this page. So if you want even more practice, feel free to do all of the others. But for right now, we're going to look at numbers 2, 3, 4, and 8. So number 2, a stone is thrown horizontally with a velocity of 30 meters per second. So my VIX is 30 meters per second, and then of course it's going to come down. Okay, so in the x direction, VIX 30 meters per second, AX 0 meters per second squared. In the y direction, VIY is 0 meters per second, AY 9.81 meters per second squared down. From a cliff that is 80 meters above the valley floor. So this distance is 80 meters, so that's my delta dy, 80 meters down. How long will it be before the stone strikes the floor? How far from the base of the cliff will it land, and what is its final velocity? So we're looking for delta t, delta dx, and then vf. So to get delta t, we're going to start in the y direction, and we're going to use delta dy is equal to viy delta t, 1/2 ay delta t squared. VIY goes to 0, delta t squared is equal to 2 delta dy over a. So 2 times 80 divided by 9.81 meters per second squared. And because everything's going down, we do not actually have to put in our negatives. Okay, so don't forget to take the square root. You should get 4.03855 seconds. All right, once you find that, then part B should be pretty straightforward. It wants to know how far away, so you're looking for delta dx. And it's equal to VIX delta t 1/2 AX delta t squared, but of course the AX goes to 0. It told us it was thrown with an initial velocity of 30 meters per second. And we just found the time to be 4.03855 seconds. So delta dx should be 121.1565 meters. I did give you the answers. I should be checking them. I guess depending on where you rounded your time, so my answers there are a little bit different because I clearly rounded my time a little bit. All right, and then what's the final velocity just as it's about to hit the ground? So you're looking for your VF, which means you need your VFX and your VFY. Well, VFX is going to be easy because AX is 0, so VFX is just going to be equal to VIX. So it's going to be equal to 30 meters per second. VFY, we can find, you could do VFY squared is equal to VIY squared plus 2AY delta dy. VIY is 0, so 2 times 9.81 meters per second squared times 80 meters. And this is probably the safe one to use just because none of these numbers did you find. Times 9. It's harder to do in my head though. Oh, and then remember to take the square root. So 39.6182 meters per second. And of course that's down. So once you have these two, then you draw it. 30 meters per second. 39.6182 meters per second. So the final velocity will be this. So square them, add them together, take the square root, and you should get a VF of 49.695 meters per second. And find this angle here because that is this angle with respect to the ground. So add an angle of, It's always good to do inverse instead. 52, is that what I got in the answer? Who it is? At an angle of 52.866 degrees, WRT ground. Okay, that is number 2. Number 3, an airplane traveling in a level flight of 540 kilometers per hour. So level flight again is saying it's going to be a horizontal projectile. Releases a package at an altitude of 490.5 meters. So the 540 kilometers per hour, you need to divide by 3.6. So it's a nice 150 meters per second. AX is 0. VIY is 0. AY 9.81 meters per second squared. And delta dy, they told us 490.5 meters. Okay, and it wants to know what horizontal distance does the package travel. So you're looking for delta dx, but before you can get that, you need your delta t. So it's identical to the one above. Delta dy is equal to VIY delta t, 1/2 AY delta t squared. The VIY goes to 0, t squared is equal to 2 delta dy over AY. So 2 times 490.5 divided by 9.81 meters per second squared. I believe you're going to get 100 there and then take the square root, right? 4 and divide it by 9. I can't believe I'm doing this. Yeah, 10 seconds. Once you get your 10 seconds, then do delta dx is equal to VIX delta t plus 1/2 AX delta t squared. This goes to 0. Delta dx is equal to 150 meters per second times 10 seconds. Delta dx is equal to 1,500 meters. Okay, and then part B, velocity just as it goes to strike the ground. So again, you need your VIX and your VIY. Again, VFX is equal to VIX, so 150 meters per second. Because the time is pretty this time, I might do AY is equal to VFY minus VIY over delta t. VIY is 0, so VFY is equal to AY times delta t, so 9.81 meters per second squared times 10 seconds. So VFY is equal to 98.1 meters per second. So again, draw it. So you have 150 meters per second this way, 98.1 meters per second this way, and this will be your VF. So square them, add them together, take the square root, and get 150.3. Did I? Oh, I think I might have screwed that up. Or not. Yeah, I didn't square my 98.1, I don't think. 1 squared plus 150 squared. There we go, that's better. 179.2306 meters per second. Inverse. And get an angle of, at an angle of 33.185 degrees, and again, WRT ground. Okay, we're not going to get them all in this video. Number 4. A pitcher throws a baseball horizontally, letting it go when it's 2 meters above the ground. Okay, so it's going out horizontally. And then it passes the batter 0.5 meters above the ground. So over here, it passes the batter 0.5 meters. Okay, so in the y direction, VIY of course is 0, AY is 9.81 meters per second squared, and delta dy is 1.5 meters, and both of these are down. Okay, distance from the pitcher to the batter is 20 meters, so delta dx is 20 meters, AX is 0, and I'm betting it asks us for VIX. What speed? Okay,